Aloha, Richard Halverson here. This is ITS148, and today is it is February 5th, and this is uh, the fourth class, I believe. Let me just check real quick here. Yeah, this is the fourth class of the semester, and let me share my screen here real quick. That's what I should do. 3. Okay, so here I'm looking at the syllabus, and it is, we are in week 4, and I did schedule a class yesterday, but it wasn't turning out very well. So I just decided that I'm gonna not post it and record something today. And so it turns out that in this chapter that we're in, chapter 11, we should pretty easily be able to cover the whole chapter in 1 hour. So let's get started. 11 is on modules, and modules is the way that people share code, and modules is really the way that that gives Python so much power, because it's easy to make modules, and there's modules for everything. So anything that you need help with, any math thing, or connecting to anything, or doing something on the internet, or controlling the robot or whatever, there will be a module for it. And then the coder, which in the beginning would be you, all you have to do is know how to work the module, know how to access the methods inside the module, and then that's how you would write. And then you're using your general Python programming skills of branching and looping and all that kind of stuff. And so that's so today we're going to talk about modules and how code that you write that you may want to reuse, how you turn that into a module. Okay, so we're using modules already. Whenever we have the word import up at the top of our code, which we've done like with math and so on, we are importing a module. So the idea here is let's say you have a set of a couple functions here, and you use them in this script. But in this script, you're using it where you multiply the two results of the function together. And then here you have this other script, and you use the same functions, but you do something different with those functions. But the point here is that this is repeated in both. Well, the idea here is that you create a module, and it just has those in there, and you can name it something, and then you import it up at the top here. You import them. You import the module, and then to use it, you see this name FUNCS. This is FUNCS. You say FUNCS, and then the function name, dot function name. See, so it's that easy, and so we call this a module being required by another program is called a dependency. So in this case, funcs would be a dependency. All right. This here is talking about the internet. There's this interactive Python compiler which we use. It's PY is my 3.9 Python 3.9, and here I can just and we can just it just executes Python code. Is that what we're talking about here? A programmer using an interactive interpreter wants to use a function defined in full. Write a statement that imports the content of the tools.py interpreter. Oh, we're just doing import tools. Is that what we're doing here? Yeah, okay. Anyway, so you can fill these in. And now the order in which okay, so it's possible to import a bunch of modules, but there can be some name conflicts, you know, and so this talks a little bit about the order and, you know, which one would have precedent. Let's say there's a couple, let's say you import a couple things and there's two FCTs, it's, you know, that kind of thing. Or maybe you have an FCT defined in your code and then you import a module and it also has an FCT in it. So this talks about evaluating an import statement initiates the following process to load a module. First, it checks to see if the module has already been imported. If it's already been imported, then what's already been imported is used. If it's not been imported, then an object is created and inserted in this sys modules, and then the code in the module is executed in the new modules namespace. So this is not super relevant for you at this time, this ordering, and you just have to know how it works here. So here we're in, okay, and it has to do with, you know, here we import HTTPS server and HTTPS, so HTTPS server goes in there. Here we import web. The point is that HTTP server also needs to import web page, and so since it already gets imported here, then it would get imported here, and then when it's used. So anyway, it talks about the order of which one is used, and I think the first one that's in there is the one that's used. So here's a participation activity where we can test our understanding of this. And to be honest with you, I just recently went over this, but we can look here. When importing a module, let's see, what is the question here? The order of events as they occur when a statement import executes, assuming that has not been previously imported. So executing import causes a new module object to be created and added to sys modules. So I guess we do, assuming it's not there. So it's either going to be, I did this one yesterday, see, I have the check mark already. So I'm going to see if it's this one. No, it's not. Is it this one? You have to put it back. Yeah. Okay, first it's got to check it. So okay, all right. The code of HTTPS server is executed. So this is executed. Oh. Oh, a new module is created. Darn it. See, I don't even know what I'm doing here. A new module is created. Okay. Then it's executed. No, it's not executed. The code and added to sys, forgot this part. Added to sys modules, that's what I set up here, right? Okay. And then the code is executed? No. Let's see. Well, I don't know. It's okay. Anyway, so, and I guess this will become important for you sometimes. See, I don't have a lot of experience writing large Python programs like I have in other languages, programs which would include a bunch of, you know, import a bunch of modules, and then we have this a module, you know, I'm calling for the import of a module, and something that I've previously imported calls for the import of the module, and then which one is used, and you know, so I'm, but the fact that we're covering it in this class, probably in this chapter, probably means it's somewhat important, and probably has to do with versions and so on. So you're going to want to know if something's not working, and you imported it, it's not working, it doesn't seem to be working well, then you can trace back, and this can give you idea of maybe where a bug or a misunderstanding of how your code is working. So this helps you there. All right. So this is a basic usage of import modules. Complete the import statement to import shapes. I guess we just do this. Okay. So this here, if we import it like this, and then we want to use a function inside of shapes, we have to precede the function name with shapes dot saying which module that it's coming from. So this would be, I suppose, something like this. All right. Here, okay, we've got this module here called arithmetic.py, and there's a function in there, and then we have the main module, and we import that, and then we define we define our own calculate function, and in our calculate, our own method, and with ours, we take the number that's input and we just add 5 to it, and then we return it. But in arithmetic.py, it's a different calculator. It takes a number and multiplies it by 5 and then returns it. So we're supposed to trace through and see what happens. Here's a print statement for, it looks like, using the arithmetic.calculate, and this one is using our own .calculate. So we see here that since arithmetic.calculate multiplies this number by 5, it's going to be 15 as output because we're printing it. And this one is just adds 5, so it's that. Okay, so let's see what next is. Okay, so outside we're subtracting 3 from 2, but inside we are multiplying by 3, returning. So 2 times 3 is 6. Here, this is the multiply by 3. So 2 times 3 is 6. And then 2 minus 3 is minus 1. Nice. And then this one, oh, look, we got 2 levels. Okay. Okay, so we have this module called data, and it's got it creates 3 variables, a variable called small, medium, and large. And remember, when this executes, that makes this execute. This thing just executes, and so this creates 3 variables and assigns values to them. And so, okay, so first we input arithmetic, and so we execute this, and all it is defining a function called calculate, subtracting 5 from the number. Then we input this, executing these 3 things, and then we're going to call, okay, then we define our own calculate, which adds 3 instead of subtracting 5. Okay, first thing we're going to do is we're going to calculate, we're going to do arithmetic.py, which is the minus subtracting 5 from it, on whatever small is. It's 7. So 7 minus 5 is 2. Yeah. And then we're going to calculate our own on the same number, which is 7 plus 3 is 10, right? Yeah, 7 plus 3 is 10. Okay. And the third one is okay, now this is interesting. Now, this is going to reinforce which one, when the imports are all executed, which value wins, which definition of dull wins. Okay, so first we execute blue, and that's this. And in blue, okay, so we're focusing on dull. There's a blue dull, which is powder, and there's a green dull, which is olive. Okay, so first we're going to print, this just prints them separately. Okay, it's not that big a deal. This is blue dull is powder. Is that how you spell powder? Powder. And the green dull is olive. So it's going to be olive. Okay, that should work. Now the last one's going to be, got it. Click next, sorry. Here it is. Okay, so first we're going to, it's just, okay, inside first we import second. Okay, so, and here are the definitions. There's a 1, a 2, and a 3. And here's a 1, a 2, and a 3, and a 4. Okay, this is interesting. Okay, now this one I don't know. I don't know what the answer to this one is. So we're both going to learn this one together. Okay, first we import first, and so this thing executes, and when this thing executes, it looks like this does too. So this executes, defining a 1, 2, and a 3 inside second, and then this executes. Here it uses second. Okay, well, we'll just try to trace through this. And then we define our own functions here, okay? All right, so first of all, we print 3 of 3. 3, what's 3? That's just this one. And so here we take 3, but we return I gotta have some whiteboard here for this. All right, so we're gonna do 3. This first one is what's number 1 times, okay, it's 3 times 3 to this 3 squared minus 3 times 2. Equals 3 times 3 is 9 minus 6 equals 3. So now we have, 3 returns the value 3. So print 3. So 3 of 3 is equal to 3. We had 3 squared minus 3 times 2 is 6. So 9 minus 6 returns 3. So this 3 is going to return 3 here. And so that's what's going to be printed here. So I'm going to put 3 here. It's probably going to be wrong. All right. And then I'm going to do this first dot 3. And I'm going to print that. So now I go in here and I find this 3 function here. And what this does is it does the same thing. We are doing, the 3 is the argument, and we're doing first.3. So for that one, it's going to be, this is 9 times 3, 3 times 9 minus 3 plus 4 minus 3 plus 4. Now it's like this. Okay, so it's this is 27 minus 7 equals 20. So I think this is 20. So I think that okay, so this thing returns 20. So I think that first of 3 of 3 equals 20. Okay, so that's that. Can I? Oops. What happens if I do this? Well, anyway, can I move this? How do I? Just do. Oh, I can just. Now what happens? There we go. Yeah, that's what I wanted to do. All right, so the third one, it's taking a long time, sorry. The third one is first of 4. Okay, so this is clever. So it's same operand, same argument, same parameter, 4. So that would be this one. And this one asks to do second of 3. That's importing second. So second of 3 is second of 3 is just the number times 5, isn't it? 3 times 5. Oops, I gotta go here like that, and then I gotta go like this. Okay, 3 times 5 equals 15 only. So this thing is going to return 15. This is going to return 15 to here, just 15. So first of 4 equals 15, I believe. First dot 4 of 3 equals 15. That's what I think. Now this is going to be wrong, I know. Okay, so 3, 20, and 15. All right. I should check my work, but I'm not gonna. Boom. Oh, that check. I guess it's right. Very good. Well, that's a good one. All right, finding modules. Importing a module begins with a search to find. What happens if I do this? So, okay, there's built-in modules. There's modules in the sys path. Okay, so a built-in module is a module that comes pre-installed with Python, like math, like sys, math, time. Okay, if no matching built-in module is found when you're asking for it, the interpreter searches a list of directories in the sys path. That's Windows, I think. I'd probably same kind of deal with Mac. And then there's Python path, which the programmer can set. It's an environment variable that the programmer can set, and then that will be another place where the interpreter will search for the Python program that you're trying to import. And then, okay, so let me just exit this. This is not helpful for me. Okay, so when import statement executes, the interpreter immediately checks the current directory for the matching file. I don't know. Importing a module begins to search finding corresponding. First checks a matching built. First checks for a matching built-in module. Okay, so I guess this is false, right? Because it looks for built-in module first, right? Yes. First, it looks for built-in modules. The environment variable Python path can be set to specify optional directories where modules are located. I believe this is true. Okay, I'm going to say this is true. Ding. Yes. Mathon.py is a good name for a new module. No, it's not, because that's a built-in module. And if you try to define a module called math.py, it's not going to find it, because the first place it looks for a math.py, should you try to import it, or if you say import math, meaning your module, it'll never find it, because the first thing it does is it looks for built-in modules, and it's going to find a built-in module called math. So anyway, so the answer is no. It's not a good name. Importing specific names from a module. Okay, so this is a little different. You know how when you're using a module, or when you're using a method that's defined in a module, you have to put the module name dot and then the name of the method, or a variable, let's say. But let's say you don't want to do that. Instead, you can say instead of saying import module name, instead of saying that, you can say from module name, import this method and this method, for example. So you see, like in this one here, let's say you're importing my mod, and you want to use this calculate function. If you import it this way, then you got to put my mod dot calculate function. However, if you say from my mod import the calculate function, then when you use it, you can just say calculate. It knows. All right, make sure you click around so you get the points. Import module versus from module import names. See there. Using the from keyword to import specific names. Okay, we want to use MD5 and SHA1, and so we don't have to put #lib in front of it. See, we're just using it there. We're just using it there. Let me just check something here. My mother-in-law got her Fauci ouchie today. That's great. All right. Let's see. So here, extending improve the hashing example by calling a new algorithm called this function from this, and extend the user interface to allow that function to be called. Oh, well, don't we just have to do SHA1? Oh, well, I can I'll just add SHA224, and then, oh, I see, all right, sure. SHA224, if that, copy, paste, paste, 224, then 224. What am I supposed to do? Well, anyway, that's how you would do that. I'm not sure what this is supposed to be doing, but okay, so these are some more. Okay, what's next? Executing modules as scripts. Okay, so this is pretty important. So let's say you make you know, you write a nice program here. It's got a bunch of, you know, clever modules in there, and you decide, and lo and behold, it's something, you know, like maybe how to read the input of a special, of a, you know, of some special device or something, and you know, it's you anyway. So you wrote all that, and now you would like to use just those modules in other programs. There's a bunch of code down here. There's a bunch of code down here you had that used those modules, okay? But you want to just import this whole thing. You know, you don't want to have to go in there and mess around. You just want to import this whole thing, and you want to be able to access the methods in here. But as you realize, when you import this whole thing, it's going to execute this whole thing. That's how it defines the methods you got in there. And when this thing executes, it's going to execute this code down here. So it's going to look silly. And so you don't want that. So how do you take care of that? Well, this explains the problem. What do? Well, you do this. On top of the code that you would just normally execute normally, you put this if statement. And then you indent everything so it all falls underneath the if. And so what this does is this first checks to see if this program that's running is running as the main program, in which case it's the original program and you're testing it or you're using it like the original program, or if this program was imported. And this module, or if this file, in a case, is this file with Python code in it, the main file that's being executed from the, you know, Python name file, or is it being executed because it's being imported into some other Python program while it's executing? So this tests for that. So if the name of the running program, it's a special Python variable, it happens to be equal to this, which is this is 2 underscores and then name and then 2 more underscores. If this variable happens to equal this 2 underscores main 2 underscores, you know, string, then it's the main program, and so it's go ahead, and if this is so that means it's not being imported. It means it's the main program. So if this is true, it's the main program. It's not being imported. If this is being imported, then this name would have a different value. In fact, this name would have the value of the main program that's running, or something. Yes, whatever that is. I'm not sure I said that quite right, but it's going to be some other value. In fact, I think it's going to be the value of the module. I think it says up here what it is. So anyway, that's not important what it says. What's important is that, you know, start getting into the habit of throwing this in there and just putting all your main code underneath an if statement like that, and then you'll never have this problem. So anyway, that's important. Reloading modules. Guess I'm not too familiar with this. Sometimes Python sometimes a Python program imports a module, but then the source code of the imported module needs to be changed. Oh, yes. Since modules are executed only once when imported, changing modules source does not affect the running Python instance. Instead of restarting the entire Python program, the reload function can be used to reload and re-execute a changed module. The reload function is located in the import lib standard module library. So okay. So the idea, where do I see a reload? Okay, here's where you import it. Okay, so here, this must be some Python program that's running continuously. Operating systems programs, you start them and they just continue to run forever until you turn something off, or you can turn the computer off or something, to turn the machine off. So this thing's running, and then somewhere along, it's running for days, and somewhere along the line, some module that was imported gets updated. Or let's say there's a bug. Let's say some bug in one of the modules that was imported. Some bug is discovered, so they have to fix it, and the bug doesn't happen very often. It doesn't happen often enough um, uh, where you shut down the whole system, but you want to fix it. Um, what you can do is, in the original code, you're going to have to put this reload function, which every time it executes or whatever, it just does a reload, and that means you don't have to shut down this whole program just because this thing changed. You don't have to shut it down and restart it, because this thing is going to execute when this thing starts. So if this is a program that runs for days, this thing gets executed on at the very beginning, and then anyway, so you have to know ahead of time, though, I guess, to put this in there. Okay, so that's so that can be important if you're writing Python code that's being used in operating systems. Or by operating systems, I can mean, let's say you're writing Python code to control a robot or a cash machine or something. It's on all the time, and I mean, it can be a real deliberate thing where it's Python code in a cache machine, and you got an update to a module, and all you got to do is plug in the new module, and that reload program will execute, reload the module. Okay, what's next? Packages. So packages can, instead of importing a single module, an entire directory of modules can be imported all at once, and that's a package. So this is so you've seen this. You've seen when you're importing stuff, you've seen where you have a dot there and you're importing, and you're not doing a from file import. It's just you're importing the whole file. So when you refer to these methods inside here, you got to do what you did before, which is put game.graphics. Whatever it is. See, game.graphics.terrain. So game graphics terrain. This one. You want to load this one. So anyway, that's it just adds more flexibility to modules and being able to organize them better. Standard library. Okay, so this is a standard library of modules, and we use these. So we use these. We use this. Certainly use this and this. This sys URL lib. That's for getting stuff off on the internet, web pages and stuff. All right, so here's an example of using the date time module. So we import this date time, and inside the date time module, there's a date, and then this is a method that goes along with dates to. Anyway, so So these are examples of how to use these functions. Okay, so match the behavior to a standard library module that might be used to implement the desired program. A trivia game which generates a new question at random time intervals. Well, now you'd use the random, probably. Retrieves the contents of a web page. Ah, that's this one. And then get the name of the current operating system. That must be this one. And compute the mathematical cosine function of a user-entered angle in radians. Okay, so that's that. And now we're gonna do some lab exercises here. The first one here is lab artwork label modules. So this is a project on modules, and so if you look down here at the code, there's actually 3 files. You have to notice this. There's the main file, and then there's the artist file module. It's a class, and here's the artwork module, and it's also a class. It's the artwork class, and really all we need to do is to define the constructor in each case. In the artwork module, there's the artwork class. In the artist module, because that's the name of the file, there's the artist class, and we just define the constructor. And then in the main program, we import these two. Is this the default template? Oh, this is the default template. Okay. We need to put in the 2 import statements. And I think that might be all that we need to do. Okay, so so if we look at this, we have to define this class with a constructor that initializes the artist's information. The artist's name should be none. The number of years of birth and death should be 0. So we see that the artist's name, the user, the birth year, and the death year, when we initialize an object of an artist class, it initializes that with none, 0, 0, but we are actually specifying those attributes, those properties when we call this. So you see, we read them in, and then we create an instance of an artist. We create an object, and an artist object, and then we also create an artwork object with passing in the parameters. Okay, and then we print it out using a method that comes along with artwork. The new artist this object is a argument for the artwork. All right, so first of all, let's go back and look at these artist.py here. So we want to define. We need to do a def, and we got to do this underscore 2 underscores init 2 underscores, and then we have to have self. That's always got to be the first thing. And then we're going to have these 3 parameters, and we want to assign defaults to them. There's going to be a name parameter, and there's going to be a birth year parameter, and there's going to be a death year parameter. And we want to, if there's no name that's, okay, well then we see this needs to be a colon there. I don't want to forget that. And we would say that self.name is equal to name, which is this. And then self dot, and these are, properties that we're sort of defining here on the fly. birth year, might as well call them the same thing. Birth year equals whatever this is read in, which is birth year. Called it the same variable name. Doesn't have to be, but it is. And then we also have a death, self-death year is equal to what comes in, death year. Now, we said we wanted these to be defaulted if they weren't specified. In other words, if the caller left these arguments blank. So we want that to be none. That's the default if nothing comes in, and if the default year comes in as 0, and if the default death year comes in and it's not there, if that value is not there, if it's null, then we will assign a value of 0. All right, that looks like that might take care of that. Let's go over here and look at the artwork. We need to, okay, here we're actually gonna use an artist. Let's first of all do this def init parentheses self, and then what's coming in is title, year, and artist. I'm just gonna put this, copy, paste, title, year, and artist, and we're gonna say self.title equals title, and self.year created equals, and self.artist equals artist equals artist. Oops. Year created is year created, title is title. And if these are not specified, we want the title just to be none. It's not specified. If the year created is not specified, let's make that 0. And if the artist is not specified, that is going to be an artist object. It's going to be an object of type artist. And so we're using artist. We need to import it. And to import, we need to do it this way. So we need to do from artist, and that's this artist.py. We just say artist. Import the class called artist. It's kind of confusing, but this refers to the class artist, which is referring to this class. It's in the artist file, .py file. We are right now in artwork, and so we import from the artist.py file, we import this class, which is called artist. And we need to know about artist class because we're using it here, and that's what this type is. So that might be pretty much it for that. So let's go back to main, and we're going to import both of them. So from, because we need to know about artists and we need to know about artwork. So from artist, wait a minute, what's executed first? Oh, artist first. We should probably put artist first, so that's known. I'm not sure that matters, but in some cases it does. Import artist, and then from artwork, import artwork. So that this one takes care of this, and this one takes care of that. Okay, so we're reading in 1, 2, 3, 4, 5 values like this, huh? Reading in 5 values. Copy. And I'm going to put that down here. I pasted that down here already. So we're in development mode. Let's run the program, see what it looks like. That looks pretty good. All right, so anyway, I've gotten you well on your way. You should be able to take care of that one. Let's look at the next lab here. I better not do all these for you. Okay, so this one is a little bit different. This one's kind of dumb. It's just, there's just a main program. We need to input the random number module. Basically, where it's given the code that reads a list of integers, and there's a number guess function which is supposed to guess, and these list of integers are guesses to whether or not to random numbers. Okay, this is really a dumb one. First of all, you input the random module, and you're going to use this random seed to initialize the random number generator. So we always get the same random numbers, the same sequence of random numbers using this function. And so so the way this function works is you put two numbers here, and it returns a random number in this range, inclusive. Okay, now they want us to use a seed value of 900 when we run this, and the reason for that is because there's a certain sequence for this thing to work. There's a certain sequence of they can't be random. Okay, in fact, we'll see that. So let's go ahead and start writing this. First of all, we're gonna let's see. I'm gonna actually, I think I'm gonna do where's my here's my notepad. I'm gonna copy this here. I'm gonna get this to run. Copy, paste. And okay, so first of all, we want to input the random number, which is just simply it's set up above import random. That's the name of the module that we want to import. And then for this okay, so we're using this main, and so this is going to grab a random number of 900. Or no, a random number, and the seed is 900. And then we're supposed to input 4 numbers or input a bunch of numbers, and that's going to be this. So this is going to be a string of integers, but it's actually a string of, it's a string. So, but it's of characters representing integers, and this is going to split them into tokens. So it's going to be 1, 2, 3, 4 numbers, 4 integers here. So we loop through them. They're still strings, but this converts each one of them individually into a number, and then we call this number guess program to guess. So the number guess is going to grab a random number, and it's going to test to see if this token equals the random number. It's kind of dumb, but so first of all, I want to show you. I'm gonna write here. Right here, I'm just gonna throw something in here. I'm gonna do for I in range of 10. Print random. Okay, so the way so let's print out the random dot rand int. That's this function here, this rand int, between 1 and 100. Are we supposed to use? Yeah, between 1 and 100. So so we're supposed to choose a random number between 1 and 100, and then we're supposed to test. So here we read this number in. We choose a random number between 1 and 100, and we see if this number is equal to or less than or greater than. And then we take this number, and then we read another, we come up with another random number, and we see if this number is equal to that random number. See, it's really dumb, but that's the way this code is supposed to work. So what I'm going to do first is I'm just going to write a little program here that's going to print out 10 random numbers, okay? And then I'm going to do, okay, so all this is going to do, is this going to run? This might not run. I got to put something here. Let me put, get a random number between one. I'll just do that. Rand num equals random dot rand int 1 to 100. And okay, because I have to have at least one statement inside this. By the way, this should be random. All right, now all this is this is a little program that's going to print out the first 10 random numbers using a seed of 900. It's going to be the first 10 random numbers using a seed of 900. So I'm going to save this. And have I been fiddling with this? Yes, I have. Let me clear this, and let me do. Let me just run the program. Py run my Python program, and this is the first 10 random numbers. Okay. Now let's run the same program again. Oh, look, it's the same 10 random numbers. Let's run it again. Oh, look, it's the same 10 random numbers. They don't look so random. And by the way, look at what they are: 80, 30, 48, 97. Now, look at these numbers we're supposed to test. 48, okay, so that's what I see. 80, 30, 48, and 97. Okay, that's those random numbers. If we should happen to change it to a different seed, you know, 905 or whatever, just any seed, it works the same way. It's a different set of they are different numbers, but it's going to be the same. It's still the same each time. See, 80, 33, 95, 46, 80, 33. So basically what we're learning here is that this random number function does produce a sequence of random numbers, which is supposed to mean that there's no relationship between one and the other, between each other or anything, no random, no patterns or anything. But when you're testing code, sometimes you want the same sequence of random numbers, because if you're running on some random numbers and you get an error, you want to be able to replicate the error. So, but if you're using random numbers, you know, that's kind of, you know, so by initializing it with a seed, you know, what you normally should do is, if you really want everything to be random, is you initialize the seed with a random number, okay? And every time you start up again, you initialize it with a different random number. Then everything's going to be truly random. But in this case, we don't want to do that because we want to be able to test our code. Okay, so I'm going to take out these comments again, and I'm going to take this code out here, which I threw in there just to. Okay, so the first thing, so this code down here is fine. So the first thing we want to do is get a random number between 1 and 100, and this does that. And then we want to test if this number coming in, if num is equal to this random number that we just got, if they're equal, then we can say, lo and behold, is the number, or whatever, however you're supposed to write it. Okay, this might not be the right way to write it, and we're going to format that with num. Okay, so all this means is this is the format. This is what we're going to print out, and in place of this thing, put that. So this says, you know, so brought in a number, grabbed a random number. Lo and behold, the random number was the same as the number that you predicted the random number would be. Otherwise, ELIF, E-L-I-F, if the number is less than the random number, then you want to say that that number is, the number that you passed in is too low. It was less than what the random number was, and then we can say what the random number is, just so we're being kept honest here. Keep my quotes consistent. All right, and then you got to do the else case. Okay, so let's see what this looks like right now with these four numbers, and this probably isn't going to work because my code is not complete. Let's run this. Oh, I got to put in the. Okay, so line 24 module number guess. Something's wrong with this. In line 11, replacement index out of range for positional arguments. Because I had two of these. Oh, it must mean I got to do this. Forgot this. Forgot about the second one. Let's see, does this work? Okay, so 80. Okay, it didn't get the middle one. It didn't consider 45 simply because I didn't finish this if then else, so it didn't print anything. If the number that was guessed, if the number that was read in is greater than the random number, it does nothing, and that's why here it only addressed those 3 out of the 4. So anyway, so you can fix this. You can fix this. All right, let's look at the next one. This next one is actually easier than it looks. So what this is it's a quadratic formula problem. We're supposed to implement this quadratic formula function. It takes 3 arguments, A, B, and C, and it computes 2 results of the quadratic formula. It's basically these 2 equations, and you input A and B and C, and then it computes x1 from A, B, 2 A's here, 2 B's, and a C, using this calculation here. And then also we're going to create an x2, which is also uses B's and A's and AC's. It's B squared minus 4AC minus over 2A, but this one is minus B plus this whole thing on top here, then after that divided by this. And this one is minus B minus this expression, this square root expression here, and then you divide the whole thing by 2A, and then that calculates x2. And then that's all we do. We just have to return, just return x1 and x2. We read in A, B, and C, and we return x1 and x2, and we better make sure we import the math module. So let's, so I'm gonna copy this code here. I'm gonna do a ding, ding, and I'm gonna go over here and I'm gonna do a ding, ding, ding. And so here we are. Yes, so I just have to write this code right here. First of all, I want to import the math module. So I'm going to import math. The reason is because I'm going to be using the square root function. I'm going to be using the square root function. Okay, so I'm going to pull up my whiteboard here. Clear canvas. And I want to convert this into a formula. I want to convert this into a formula that's one line. So do I need my whiteboard? I don't know. Let's see. It's going to be minus b plus the square root math SQRT of something this whole thing divided by whatever the 2a is. This 2a here. So I don't think this is going to work very well. So here. So this is 2 times a. And this is minus b plus mass. And so this inside here is going to be b times b. Okay, that's this b squared. Minus 4 times, minus 4 times a times c. Okay, so that's the first one. And the second one is just going to be, this is x1 equals this equals x1. And x2 is equal to, same kind of thing, I'm going to see if I can write smaller, minus b minus math SQRT, oh, the same thing. Same thing. All the way across is the same thing. B times B minus 4 times A times C. Close this parentheses. This is an R. Close this parentheses, this one here. Divide the whole thing by 2 times A. Now, we don't need to put the parentheses around 2 times A because all of this divided by 2 and then multiply the whole thing by A. Is that right? No, that is not. We do put parentheses around here. Oops, let's put parentheses around here. Something else. Okay, because see, so it's divided by this whole thing. If we would have not put the parentheses, then it would have been divided by 2. First, it would have been divided by 2, and then the whole result would have been multiplied by A. We don't want to multiply this whole result by A. We want to just multiply the A by 2, and then that's what we want to divide. So it should be like this. Okay, so that's our equation there. Let's see if we can just write that just while we're here. I'm going to go down, put this down like this, put it over like this, and I'm going to put right here, I'm going to put x1 equals parentheses minus b plus math.sqrt parentheses b times b minus 4 times a times c, close, divided by, open parentheses, 2 times a, close parentheses. Okay. And so now inside here, it's going to do this multiplication first, then it's going to do this multiplication, and then it's going to do this where it multiplies it by the c, and then after it's all done with that, it's going to take whatever this product was and subtract whatever this product was. So the operator precedence works fine inside the square root parentheses. We want this to be done first, and then we want to divide this whole thing on top, divide that whole thing on top by this whole thing on the bottom. And x2 is the same. I'm just going to do copy paste. x2 is the same, except for it's x2. That's plus. That's plus. Yeah? No. Oops, minus. It's minus. Yeah. Plus here, minus here. Okay, so now this might be all we need to do. Okay, so let's see if this is all we need to do. I'm going to save this, and I'm going to go here, and the numbers. See, when it asks for numbers, it is asking for an input line. Okay, so it's asking for A, B, and C. Yeah, A, B, and C. What is A, B, and C? It's asking for this. This is A, B, and C. Copy. And let me go over here and run this. A, B, and C. Solution to this looks like that, looks like that. x1 equals 7, x2 equals 5.5. Okay. Well, anyway, that looks pretty good. Let's see, is that it? Yes, next is chapter 12. Okay, well, thank you very much. We have finished chapter 11, and we did chapter 12 last semester, so next week we'll start on chapter 13. Thanks for watching.